Hello, my name's Dr. Liam Brierley. I'm an MRC Skills Development Fellow here at the University of Liverpool. Now, as humans, on some small scale, every one of us uses information in our daily lives. Data science and statistics is the process of using information on a much bigger scale to really understand more about the world that we live in. Data science is a big umbrella that covers all kinds of empirical science, and it's a bit like a set of tools to understand the world. Now, recent trends in the wider world have taught us that more than ever, global change needs to happen through rational and evidence-based means. I use a variety of types of data about wild animals and the pathogens they carry, from ecological habitat and conservation status, right down to clinical pathology and genetic sequences. I then use this information to construct models to understand what drives this complex process of a pathogen moving from one species to another. Now, because of changes to technology that generate these data, like text mining and high throughput sequencing, we've now got exponentially higher volumes of information than we did even 10 years ago. So newer approaches to these models are always needed. There is a continual risk of new viruses transmitting from animals to humans. And although few spread to become epidemic, COVID-19 has reminded us that when this does happen, there can be enormous burdens to global health and economies. By using bigger and bigger scales of input data, we're getting closer to the ultimate goal of identifying and interrupting that cross-species transmission of new pathogens before they become pandemics. There isn't one mold for a data scientist. Strength in maths can be really helpful to work in the theoretical side, but it's not a requirement to work with applied data. What's more essential is critical thinking and effective communication. A computer can resolve the maths, but only a human can interpret a story. My experience is in academia only, but so many applied fields of study have become so much more quantitative over the last decade. Where biology used to be the exclusive domain of biologists and sociology used to be the exclusive domain of sociologists and so on, there's now so much more scope for working in interdisciplinary teams with computer scientists and data engineers. I grew up in what is a very traditionally low-income area of the Northwest. The local authority area that I went to school in was one of the lowest performing in the UK. When I was growing up, there was this idea of whether I was going to go to university or not, and I did think I would go to university, but I didn't think I would do anything beyond an undergraduate degree. Like, these ideas of doing a master's or even doing a PhD were just so far beyond where I grew up that it never even entered my brain as an idea that, I could do that I would be capable of that, because I used to just think, well, this isn't what people like me do, because I wasn't seeing it anywhere. And so I think it's really important to help younger people realize that their potential is not tied to who they are or where they come from. Diversity is really super important for working in science or any other industry. It's been shown that more diverse teams achieve better results and have more diverse ideas. The kind of skills you're going to need in data science are really those important critical thinking skills. Now, that can come from a STEM background, but it can also come from different other types of background. If you've done any kind of projects where you've had to think rationally, you've had to think about evidence and where it's come from, you've had to think about whether there might be biases in what you're seeing. In a way, that's exactly the kind of critical thinking skills that data scientists, and to be honest, probably all of us, need a little bit more of.